She has also published three papers in national conference. Presently, she is working on MRI images which are available online to find biomarkers for early diagnosis of Alzheimer's disease. She has an experience with various MRI software tools like FSL, Free Surfer, SPM12, MRI, Cron, ANT for normalization, registration, co-registration, visualization, etc. She is also using deep learning techniques for automatic diagnosis of Alzheimer's, mild cognitive impairment, and normal subjects. She has also developed the deep learning architecture to diagnose COVID-19 using CT and X-ray images. She is using the deep learning methods and optimizing their hyperparameters for accurately automatic diagnosis of COVID-19 from normal patient. She is doing the segmentation of 3D CT scan images for COVID-19 detection. Presently, she is focusing on diagnosis of Parkinson disease and PET images. So it's our pleasure to have you with us, ma'am. Welcome to this.
Okay. Thank you, Miss Swati ma'am, for my nice introduction.
Yes, ma'am.
And thank you, Dr. Ujwala, for your invitation. So it is my pleasure to accept this invitation and present in front of all of you. So, ma'am, may I start my presentation now?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes,
So
ma'am.
this is visible to everyone.
Yes, ma'am, it is visible.
Okay, thank you. Okay, so myself is Dr. Trupti Goyal, currently working as an assistant professor at National Institute of Technology, Silchar, Assam. And the topic of today's seminar is multimodal fusion-based deep learning network for effective diagnosis of the Alzheimer disease. So first, I want to tell about my institute where I am working. So I'm working in NIT Silchar. It is one of the 31 National Institute of Technology of India, and it was established in 1967 as a regional engineering college in Assam. In 2002, it was upgraded to the status of National Institute of Technology and was declared as an Institute of National Importance under the National Institute of Technology Act 2007. So these are some photograph of our institute. Our vision of NIT Silchar is establishing unique identity by development of high quality human and knowledge resources in diverse areas of technologies to meet local, national, and global economic and social need and human society at large in self-sustained manner. And the mission of NIT Silchar is to train and transform young men and women into responsible thinking engineers, technologists, and scientists to motivate them to attain professional excellence and to inspire them to proactively engage themselves for the betterment of the society. So these are the some major achievements of NIT Silchar. So in QS ranking, World University ranking, we have 19th place in India, and it is in the rank of gap of 801 to 1000. It also ranked in 11 to 25 in the ATAL ranking of institutions for innovation achievement by the Ministry of Education, Government of India. NIT Silchar has been selected as the host institute for the Technology Innovation Hub under National Mission for the Interdisciplinary Cyber Physical System in the Technology Vertical for Cognitive Computing and Social Sensing. NIT Silchar has been ranked 46 in the engineering and 94 in the overall ranking and 9th place in overall NITs in India, and thereby entering the top 100 in the overall ranking for the first time since the inception of NIRF ranking by the Ministry of Human Resource Development, Government of India. Now I will start with my presentation. So I will start from the basic of machine learning. From machine learning, I will move towards deep learning, then medical imaging, and then application of deep learning and machine learning for the Alzheimer disease. So first main question is, what is machine learning? Machine learning means to learn the machine as we think, as a human thing. So it is a learning is a process by which system improve the performance from the experience. We have set of input and output, and from that experience we learn the machine to act intelligently so that it can work like a human. As per the Tom Michel, he gave the definition of machine learning is a study of the algorithm to improve the performance for the some task with some experience. That experience is the a pair of input and output. So for the desired output, what should be the input? Accordingly, machine will learn and it will act accordingly. So this slide shows the basic difference between the traditional programming that we have studied in our 11th and 12th and the machine learning. In traditional programming, we have some data. For that data, we have some program. And from that data and program, the computer will miscalculate some output or the response. But in case of the machine learning, we have data and output. Means we have the pair of input and output. We can say it, we have the training data and the target data. And we have to model a network according to that relation so that we get a program. Means it is a black box. So that black box is trained using the input and output relation. So in machine learning, input and output relation is given, and we have to develop a network, a program, or an architecture so that for the given data we can get the desired output. So this is a basic difference between the traditional programming and machine learning. So now there are the four types, mainly four types of the machine learning. First one is supervised learning. In supervised learning, we have training data as well as a target data. Means for the desired input, what should be the output, and accordingly our network will learn. Second is the unsupervised learning. In unsupervised learning, there is no any label, no target is given, only some data points are given, and it is our task or it is the task of the machine to categorize this or to label that data into a particular category. Next is the semi-supervised learning. In semi-supervised learning, it is a combination of supervised and unsupervised. Means training data is given, but the desired output is given for the few output only. And the last one is the reinforcement learning. Reinforcement learning is a type of the supervised learning, but it in this case machine learns by the rewards. Means some task is given, in that task environment is given, agent is given. So it will learn that task according to the rewards. So we will study all these type of learning one by one. So first come supervised learning. In supervised learning, we can have regression as well as classification. Meaning of regression is we have a set of data, input and output relationship is given, and we have to give some value. Means it is analog in nature. We can take an example like very famous problem, that is house prediction price problem. So house prediction price, for example, depends on the it depends on the square feet of the particular flat. So that particular flat price is given. So first we have training and testing data is given. Now for the testing data, if we want to get the know the price of that house based on the model, then this problem is called the regression problem. Like in this problem, it is given that on the x-axis some this years are given, and on the y-axis we have the September Arctic sea ice extent is given. So in this case, this blue square denotes the data points. These data points are x1, y1. For the particular value of x, we have given the value of y1. Now we have to draw this regression line, or we can call it as a boundary line. So whenever some test data is given, for example, some test data is given for the year 2001, So we will draw a straight line to this green line or red line. Accordingly, we can calculate the extent of the ice level in that particular for that particular data point. So regression is a continuous problem in which we will get some value. Next example of the supervised learning is the classification. Classification means what? Some test data is given and we have to classify that data into a particular category. It can be used for the face recognition or object recognition. It can be used for in the medical imaging also. If we have to diagnose some disease, then also we can use supervised learning for classification. So in classification, it may be binary class or multi-class. Binary class means if it is yes or no. And multi-class means, for example, if we have to diagnose the cancer, in cancer we have total 4 stages. So if we have one example is given, test data is given, and if we have to categorize that test data into either of these 4 categories, then this type of problem is called the multi-class classification. So here in this slide, a simple example of binary classification is given in which we have the example of breast cancer. So this breast cancer mainly depend on the tumor size. So on the x-axis, we have this tumor size. So these blue dots define there is no cancer. It is called benign, and this red dot it denotes the malignant. So again, we have some features are given which are represented by x1, y1 up to xn, yn. So x is the input and y is the output. So accordingly, this graph has been made. So now we have trained the machine learning or any neural network according to the data given here. So accordingly, the classifier or the network has differentiate between these two categories, whether it is tumor or not. So whenever any test data comes, if it falls in this category, then we can categorize them that there is no tumor, or we can categorize them in benign category. And if some test data come which falls in this category, then we can say that it is malignant, means there is a tumor. So this is a problem of classification, and in classification the output is always discrete in nature. It is a basic difference between the regression and classification. In regression, output is always continuous, or it is analog value, because we need some value for the particular data sample. But in case of the classification, we have to categorize the test data or data sample into a particular category. So output of the classification is always discrete in nature. So in the previous slide, we have taken only one feature, that is tumor size. So if we take tumor size, these two data points, they have almost same tumor size. So using only one feature, it is very difficult for the network or for the machine to differentiate between the malignant and benign. So in this type of case, what we do, we can take two features. So this slide shows the same problem that we have addressed in the previous slide, but in this case, differences in the number of features. So now it is a two-dimensional problem. In this case, we have taken two features. First one is tumor size and second one is age. So this blue dots define the zero category, means benign, and this red dots define the malignant category. So we see the separation between these two classes, and accordingly this decision boundary has been plotted. So if some data point is given or some test data is given, if it falls under this boundary, then it will be classified as benign, and if it falls above this boundary, then it will be classified as a tumor. Other features we can take for the more accurate result, that is clump thickness, uniformity of the cell size, uniformity of the cell shape. So as we increase the number of features, the performance of the particular classifier will become more. But side by side, we have to take care of the computational complexity of the network, because increase in the features will also increase the computational complexity of the network. So there should be always a trade-off between the features, number of features selected, and the computational complexity of the network. Now, this slide shows the example of unsupervised learning. So, as I already told you, the main difference between the supervised and unsupervised learning, in unsupervised learning, we have no any labels. We have no any targets, only data samples is given. But in case of the supervised learning, we have data samples as well as targets. So that's why in this case, all the data are represented by only using x1, x2, xn. So in the case of the unsupervised learning, there is no target, there is no y is given in the unsupervised learning. So in the previous slide that we have done, only we have used the color dots, whether maybe it blue, red. In this also we have used color dots. But in case of the unsupervised learning, the basic difference is that we have no any labels. So all the dots are of same colors. Now it is a task of the classifier, or it is a task of the network based on the similarity measure between the data point. First, it will cluster all the data into a particular label. So it will calculate the similarity between each and every data point, and accordingly it will classify or it will categorize each data into a particular labels. So after doing the training of the machine learning network, all these data points are now labeled into three categories, which are denoted by this red color, blue color, and red color. So this is the task of the unsupervised learning. So here is a real-time example given in this slide for the unsupervised learning. For example, in a room, there are two or three musicians or speakers, and we have to differentiate the voices of first speaker and second speaker. So in a crowd, based on the similarity between their pitch, their voice tone, and other characteristics, it is a task of the unsupervised learning to classify or to differentiate between the voices of the speaker 1 and speaker 2. So it will take different characteristics like the pitch of the voice, tone of the voice, some frequency domain features it is also taking. So based on all these features, the machine will categorize or cluster the all the voices into two categories. These categories are speaker 1 and speaker 2. Now the third one is the reinforcement learning. So reinforcement learning is also the form of the supervised learning. In this also we have the input and targets. So from the input and targets, the machine will learn. But there is a big difference between reinforcement learning and the supervised learning. Reinforcement learning learn by the rewards. Some rewards will be taken, will be given to the user. It may be positive or it may be negative. So if the reward is positive, it will learn. If it is negative, then it will discard that action. So it is mainly used for the game playing. For example, we have to play the chess. So I think all of you have known about this chess play. So in the chess play, if we move one step, so what will be the action of the other player? So whether it is positive or negative, accordingly reward will be given. If that move is okay, then positive reward will be given. But because of that move, another player can cancel out its mark. Then it will be then negative reward will be given. So according to the rewards given to each an action, the machine will learn which action next action should be taken. So mainly in the game playing or robot, we use the reinforcement learning. Another use of the reinforcement learning in the autonomous or self-driving car. So in USA, already self-driving car are come into the road. So main operation, main task or main idea behind the self-driving car is the reinforcement learning. So for example, traffic light is there. If red light is there, car is moving or car is stopping. If car is stopped, then positive reward will be given. But when traffic light is red and car is moving, then negative reward will be given. So by this way, the machine will learn whether it is taking action correct or wrong. So if it is a positive reward, then it will be taken. If it is a negative reward, it will be discarded. So this is the mainly difference between the reinforcement learning and the supervised learning. So these are the various applications of the machine learning. It may be used for the image processing, computer vision, marketing, natural language processing, manufacturing, in medical imaging also for diagnosis, speech recognition, bioinformatics, gene expression, object recognition, fraud detection, in multimedia security. So the students or the research scholars from various streams can use machine learning, whether it may be from mathematics, computer science, electronics and communication engineering, electrical engineering. Algorithm. This slide shows the basic sequence of the learning process. So in the learning process, for example, some data is given. The data is measured using the sensors. These sensors may be your camera, maybe your mic. If some image is there, so obviously camera will be the device which take the picture, and then it will be given to the system. When there is a voice signal, so obviously some mic will be mic will be there, which will listen or record that voice, and then it will be given to the system. For video also we use camera. So some sensors are there which take the data from the real world. Next step after the data acquisition is the pre-processing. So data that has been taken from the real world, maybe it is not adequate for the machine learning process or any neural network or any for the learning. So first we have to make this data adequate for the machine learning. It may include removal of the noise, removal of the outliers, or resize of the image, or we have to convert color image into black and white image, or we have to extract some useful features from that data. So all these steps are included in pre-processing. So pre-processing means normalization of data, removal of the noise, feature extraction, or bias correction, resize of the image, so that the data which has been taken from the real world, which are captured using your camera, your mic, or any other sensor, it will be adequate for your machine. Next is the dimension reduction. So data we have captured from the sensor, the data size may be very large. For example, if we take the video, that video may be of the size in GB, at least or MB. So for machine learning, it is very difficult to process the data of this much of size. So obviously we have to extract some important features from that data so that the machine learning algorithm or any neural network can process that data very easily. So this includes feature extraction and feature selection. There are various algorithms in machine learning which are used for the feature extraction and selection. For example, principal component analysis, independent component analysis, linear discriminant analysis, local binary patterns. So some mathematical feature extraction algorithms are there. You can work on that algorithm for the feature extraction and feature selection. So after feature selection, now that data will be given to the machine for the model learning. Now these features are sufficient. It should be sufficient so that it can learn the machine to get the desired output. So in that feature, obviously we have input and output relations. Input is given, output is given as the target. So first input is given, output at the output, the predictive value is compared with the target value. If it is okay, then the machine learning model will be trained. And if there is some error, that error will be propagated back to the input. And accordingly, all the parameters of the neural network or machine learning algorithm, these are the weight and biases, these will be updated according to the error which we get by comparing the predictive value and the target value. Again and again, it will be compared. Means machine will compare the predictive value and the target value, the error will be propagated backward, and according to that error or according to that loss, the pattern, the parameters of the machine learning will be updated. So we will specify some number of the iterations or maybe some minimum error or minimum loss. So accordingly, this process will go until number of the iterations or the minimum error we got it. After that, next step is the model testing. So from the data available, we divide some data for the training and some data for the model testing. So first, the model is trained. Now obviously we have to validate or test that model. So for the rest of the 20% or 30% of the data, we will test the model. So we will give only the input and then we will check the predictive value. So for this predictive value, we will calculate the performance metrics. So these performance metrics may be your accuracy, specificity, sensitivity, precision, recall, or F1 score. Or we can draw in graphical method also, like confusion matrix, vision of convergence. So all these are the performance metrics to judge or to examine the machine learning model. So we will analyze the result. So if results are accurate, it is up to the mark, then we will consider that model or that machine learning network for our real-time data. So this is the complete learning process. So it includes data acquisition, pre-processing to normalize the data, to remove the noise or to extract the special features, dimensionality reduction for the feature reduction, feature extraction and feature selection. Then model learning, it is called training of the network. After that, model testing to test the data, to test the model for the test data, and then analysis of the result. Now this slide show the basic neuron, which is it mimics the behavior of the neurons in the human brain, and then mathematical modeling of this human brain neuron from the neuron to a mathematical model. So in this structure, we have this input and output process. So this is a basic model of a neuron. So this big one, it is called a axon. This axon carries the information from one neuron to the another neuron by using this axon terminals. So these are called the branches. This axon will be divided into branches, or it forward the data or transmit the data from the neuron to the other neurons. Other part is, this is the cell body. Inside cell body we have the nucleus, and with that we have these dendrites. These dendrites will receive the information or the data from the other neurons. So axon will travel the or forward the information from the one neuron, and these dendrites will accept the data from the another neuron. Then we have this cell body. This cell body will process the data. It will calculate the output, because in this cell body we are getting information from the different neurons. So this cell body will calculate or will process all the data which are getting from different dendrites, and after processing that data, it will be transferred to the other neurons using this axon. So this is the basic nature of behavior of the human brain neuron. Now we mimic that neuron behavior using this mathematical model. So for example, this is your cell body. In cell body, we are taking 3 input neurons. So we have 3 input data, x0, x1 and x2. So these informations are carried from the dendrites to the cell body. These inputs are connected to the cell body with different weightage. These W0, W1 and W2. These are the weights. These weights give the weightage to the input. Weightage means how much important this information is. So when all these 3 information come to the cell body, this blue color circle represent the cell body. The main function of cell body is to process the data. So the function of the cell body, it will sum all the data which is coming to it So it is represented by Wi into xi. So it will come from 0 to 2. W0 x0 plus W1 x1 plus W2 x2 plus B. B is the bias term. Why bias is added here? In case if there is no any information, means W is 0 for each and every one. So we will get 0. So if there is a 0, this neuron will not work. So to sort out this type of issue, we add one bias term here. This bias range from 0.1 to 1, so that this neuron will work. And then this output, this complete output is given to the to the another neuron. So in this way, we have mimicked the behavior of the human brain neuron in the mathematical model. This slide shows the continuation of the mathematical model of the neural network. Now again here also we have number of inputs which are coming from the different neurons. So it ranges from x1 to xm. So they are connected to the cell body through different weight. So the weights are from W1 to Wm. So all these weights along with the input will be added at the cell body. Output of this cell body is Yin. After that, this will be given to a activation function. Now, what is this activation function? It is a non-linear function. It may happen the output of this summation may go up to infinite. It may be towards minus or maybe positive infinite. And it will be very difficult to process that high value of the input to add the output. So to make that high range of the output, this Yin into the nonlinear range, we use the activation function. The example of the activation functions are sigmoid, 10H, radial basis, wavelet activation function, softmax activation function, ReLU, and the variants of ReLU like leaky ReLU, parametric ReLU. So all these activation functions are used to convert this output Yin into a nonlinear value. And finally, we will get the output. Mathematical expression of this model is given here. So this Yin is the sum of all the inputs along with their weights. After that, final output will be calculated by taking the activation function of this Yin. For neuron, we can show it like this. In this case, we have total 3 layers. First layer is input layer, second is hidden layer, and third one is the output layer. In input, will give the input. All these input will give to each and every hidden node. These are called these blue box, the blue circle. These are called the hidden neurons. And this is the layer. Complete. This is the layer. So all this input will go to each and every hidden neuron. So here this mathematical function will be implemented. Output of this will be x1 into w1 plus all this into the activation function. After getting the output of the hidden neuron, all the output of the hidden neuron will go to the output. And this output, in this case, we have only 2 outputs, so it is a problem of binary classification. So this is called the neural network. This slide shows the ensemble learning. In some cases, what happens, we have lot of machine learning classifier. In this block, it is showing MLP means multi-layer perceptron. Multi-layer perceptron means the network I have shown here. In this case, we have only one hidden neuron, hidden layer. In multi-layer perceptron, we have more than 2 number of the hidden layer. Second is KNN. KNN means K nearest neighbor. It is a type of unsupervised learning in which we cluster the given data into different labels. This K represents the number of the labels. Next is the decision tree. Decision tree means that type of tree in which we have root node and the leaf node. So based on that tree, the decision will be taken. And random forest is the combination of several decision tree. So there are many number of machine learning classifiers like sport vector machine, navi-based, random forest, decision tree, k nearest neighbor, or logistic regression, softmax. So it may happen for each and every application, single, not a single classifier will work. The performance of the for the particular application, the performance of that particular classifier is not so adequate. So what we do, we take a combination of different classifier. We mix or we combine all these classifier for the given problem. Then we take the output of each and every classifier, and then we concatenate the features of all the classifier using the voting, soft voting, and accordingly we will do the prediction. This type of learning is called the ensemble learning. So in ensemble learning, we combine n number of models collectively for a given data set to get the better predictive performance. It also reduces the chance of overfitting and underfitting, which is the main problem in case of the neural networks. So to remove the problem of overfitting and underfitting, as well as to get the high performance result, we use the ensemble learning. So now ensemble learning can work for any type of the data because it is a combination of 4 or 5 type of the learning. But the computational complexity of the ensemble learning method will be higher than the other network because it is a combination of n number of classifiers. So the computational complexity of ensemble learning will be equal to the n times of the computational complexity of the particular classifier. So this is an example of the ensemble learning classifier, how it works. So in this case, again, we have two categories are given, which are denoted by blue dot and the red dot. So during training, if we use only one classifier, decision boundary may be like this. So the accuracy or the performance of this decision boundary is not correct because if the sample, for example, blue sample is here, so one sample is here. So it may classify it as a red or maybe blue because now decision boundary is not so correct. But if we use ensemble of the classifier, so by using ensemble of the classifier, we will get this decision boundary. Now it will classify the data into a particular category with a very better performance result. Now some data point is here or here. So obviously it will be categorized into red dot. If some data point is here or here, obviously it will be categorized into blue dot. So we have no any confusion like this one. So this is the advantage of ensemble learning over the single classifier. Now, till now we have studied only about the conventional machine learning classifier. So this slide shows the mainly challenges which are faced by the this conventional neural network. So this block diagram on the right hand side shows the uh, complete neural network that is used for the categorization of the particular data. First step that we have already discussed is the data acquisition, then data normalization, feature extraction, classification, and then result analysis, which is done by the testing the model. So conventional machine learning classifier consists of all these steps. It consists of data normalization also and feature extraction. So this data normalization and feature extraction, it depends on the data given. It depends on the classifier. It depends for which data, for which application we are using it. Data normalization, maybe some data has more noise, maybe some has no noise. Some has outliers, some data has no any outlier. Some images have illumination variation, some images has expression variations, some has color variations. So we have to choose, or it is a tricky thing that which data normalization we have to use. And all this normalization consists of lot of mathematical calculations. Next is a feature extraction. We have to obviously extract it manually. So for each and every application, we have to use different feature extraction algorithm. It may be PCA, It may be ICA, LDA, or it may be LBP. For different applications, there are different feature extraction algorithm, and it will take time and it requires a lot of mathematical calculations. Next is the classification. Obviously, for each and every data, there is not specific any classifier. We have to test each and every classifier for that particular classifier for that particular data. It may be SVM, KNN, logistic regression, maybe decision tree, random forest, or maybe perceptron. So we have to check all the classifier. Then we have to analyze the result. The for the particular classifier for which accuracy or the performance is the best, we will take that classifier. So it is also a very time consuming task, and it depends on the data or the application we are using. So these are all the limitation of the conventional machine learning classifier or neural networks. That's why now in today's era, all the researchers, all the software engineers, now they shifted their interest from machine learning to deep learning. So it is a modern age of the machine learning or artificial intelligence. So this slide shows the difference between the machine learning and deep learning. So I have already discussed in the previous slide, machine learning consists of the data normalization, feature extraction, classification, and then analysis of the result. But in case of deep learning, it consists of set of hidden layers. It consists of number of set of hidden layers. And task of these hidden layers, it will do automatically all the data normalization, feature extraction, as well as classifier. That is the advantage of the deep learning, and we can say it is the main difference between machine learning and deep learning. So in deep learning, we have to just give the input, the machine, the network or the model, it will automatically normalize that input, extract the feature, and classify it into a particular category. So that's why now all the researchers is attracted towards the deep learning, whether it is for the self-driving car, whether it is for the marketing, whether it is in the domain of the medical image, whether it is for natural language processing, anyone. So all the researchers, all the attentions are now moved from the machine learning to the deep learning because of its main disadvantage. Also because it is using a number of the hidden layers. So as the number of hidden layer increase, the performance of the network will also increase. So the accuracy of the deep learning network is more than that machine learning network. So previously what happened in deep learning, because it consists of lot of number of hidden neurons, so it requires lot of computational. So we require computational power. So in the previous system only we have CPU. So in that CPU this type of the computational power was not possible. Now from 2000 we have GPU also. GPU stands for graphical processing unit. So with the advent of the GPUs, now we can run deep learning in that workstation to get the particular output. So by the advent of this GPU system workstation, we can use deep learning in any type of the situation. It can be used by any domain expert for their application. This slide shows the basic building block of a typical deep learning network. So for example, some input image is given. This image shows the MRI image. So in this case, first layer is called the convolutional layer. In the slides we have seen, in these slides, each and every input is connected to each and every hidden node. In case of the convolutional network or in case of the deep learning network, for example, one image is given whose size is 256 is to 256. So if we connect 256 into 256, all the neurons to each and every neurons of the hidden neuron, then it will become very complex. And to sort out that issue, what we do, we replace that hidden layer with the convolutional layer. Convolution layer perform the convolution function. It perform the convolution function. So we have the feature map, we have the convolutional kernel, the size of the convolutional kernel will be defined by ourselves. Just wait for 1 minute. I have to attach charger. Yes, I'm audible.
Yes, ma'am.
Yes, ma'am.
Okay, so that hidden layer, number of hidden nodes. Now these are removed by the convolutional layer in case of deep learning network to reduce the number of connections between the input image and the hidden layer. So the number of the convolutional kernel and the size of the convolutional kernel, it will be decided by ourselves. So when we convolve or do the convolution of the input image with the convolutional kernel, we will get the feature map. This is called the feature map. So after feature maps, next layer is the pooling layer. What is the function of pooling layer? The size of this feature map may be very large. So we have to reduce the size of the feature map. So we use, there are two types of pooling. It may be max pooling or average pooling. So by using pooling layer, we reduce the size of the feature map. And after this deep learning layer consists of a stack of the convolution layer, pooling layer, and the activation layer to get the high level of the features. After this, next layer is the fully connected layer. After the final layer of the feature map, we will vectorize all the features into a column vector. And this layer is called the fully connected layer. This fully connected layer, output of this fully connected layer is given to the classifier. In most of the deep learning network or convolutional neural network, we use softmax classifier. The advantage of using softmax classifier is that it is a multi-class classifier. We can use logistical classifier also, sigmoid also, but the main drawback of the sigmoid classifier is that sigmoid classifier can be used only for the binary classification. So, inbuilt by default, softmax classifier is there in every deep learning or convolutional neural network. After this classifier, we will get our particular output. So this is the basic building block of the basic architecture of any deep learning network. So I will explain each and every layer one by one. So the first layer is convolutional layer. So the task of the convolution layer is to extract high level of feature. So already some pre-trained deep learning networks are available in Python library, also in the MATLAB library, like our Resident 50, Resident 101, Resident 18, Inception Net, Squeeze Net, Mobile Net, VGG Net, VGG 16, VGG 19, Efficient Net. So already these nets are given. These pre-trained deep learning networks are given. So in these networks, there is a stack of convolutional layer. For example, in ResNet 50, we have total 50 convolutional layer. In ResNet 101, we have total 100 convolutional layer. So as we increase the number of the layers, this convolution layer, the features which are extracted, it will become more concise. We call it as the high level features. High level features mean it will extract each and every detail of the data. That data may be image, maybe video, or maybe some speech signal. So high level features means it will extract each and every detail of the data. So how it do the convolution? For example, this is the input matrix, which is your 5:5 matrix, and one convolution kernel is given. So first one window is here, that is 3:3. it will do the convolution. Convolution means it will multiply it. After multiply each and every element, it will sum it, and after sum we will get finally answer. Next, it will move this window by 1 horizontally as well as vertically. So if we move this window horizontally by 1, again this will be your window size. It will multiply each and every element, then add it, and then calculate the second element. For the vertically, it will move towards vertical, multiply each and every element, then add it, and then calculate the next element. So this is what this is convolution is going here. So the use of convolution to extract the each and every detail of the data. Next is the activation function. I already discussed the main role of the activation function is to convert the data into nonlinear form. Means it may be go to the minus infinite or plus infinite. So it will give it into a particular range. It may be 0 to 1, minus 1 to 1, or it may be minus 5 to 5. So the data, whatever be the size of the data, it will keep it in a particular defined range. So in deep learning network, mainly we use ReLU as an activation function. ReLU stands for rectified linear unit. So here the example is given. The mathematical expression for ReLU is given as fx is equal to maximum 0, x. What is the meaning of this? Whenever there is a negative term, it will be replaced by 0, and for positive integer, it will remain as same. So for example here, 4:4 matrix is given, and after applying ReLU activation function, we get this output. So the positive value will remain same like 15, 20, 35 other values. And wherever we have the negative value, like here minus 10, minus 110, minus 15, minus 10, all these negative values will be replaced by 0 as per this expression. This is the mathematical representation of this ReLU activation function, and this is a graphical representation. So for the negative value, output will be 0, and for the positive value, output will remain the same. Other variants of ReLU are the leaky ReLU and parametric ReLU. In leaky ReLU, for the negative value, a little slope will be there. It depends on us, whatever we have to take the value, but for the negative value, it is not complete 0. Some value will be there, but that value is very small. Next variant of ReLU is the parametric ReLU. For parametric ReLU, a constant value is given. Instead of 0, we have 0.1. So for the negative value, we replace all the negative value by 0.1 in parametric ReLU activation function. Next layer is the pooling layer. So pooling layer are used to reduce the size of the feature map. So for example, this is your feature map, which is 4:4 matrix. And by using the pooling, it may be max pooling or it may be average pooling. So by using pooling, we convert the size of this 4:4 matrix into 2:2. So the size of the feature map will become half by using pooling layer. And if we reduce the size of the feature map, obviously computation complexity will reduce, and time required for the training of the network will also reduce. So this is the advantage of the pooling layer. Now I come to what is the meaning of max pooling and average pooling. So in max pooling, first we take a window. For example, it is given that 2:2 window we have to take. So for this window, we take the maximum value. So for this red color box, maximum value is 20. So this complete block of 2:2 matrix will be replaced by a single value, that is 20. Next, for this box, which is represented by this yellow color, in this case 30 is the maximum value. So this complete block will be replaced by 30. In the same way, we can replace this blue box and this green box by their maximum value, which is 112 and 37. So in this case, we are taking the maximum value of each and every block. That's why it is called max pooling. Next come our average pooling. In average pooling, we take the average of each and every block. So in this case, this block is, we have 4 elements, 12, 20, 8 and 12. We will calculate the average of all these data points. it will come 30. So we replace this block by a value 30. In the same way, we will do for each and every 2:2 block. So this is how pooling works. It converts the size into half by using either max pooling or average pooling. Next is a fully connected layer. So fully connected layer, all the data from the last layer of the feature map, it is converted into a vector. This vector is a column vector. This is a column vector. Now it will go to the classifier. It may be softmax classifier. For binary classification, we can use sigmoid classifier also. Loss function may be this cross entropy, maybe mean square error, mean absolute error. We can select any type of the loss or error, and after that the input data will be categorized into a particular class. So this is a complete deep learning network which consists of convolutional layer, activation layer, pooling layer, fully connected layer, classifier, and finally the output. One special type of the deep learning network is there, which is called generative adversarial network. It was discovered, or it was implemented in 2017. So now some researches are also going on this GAN. So what is the main function of GAN? It generally synthesizes the data. It generates the fake images of the given data. For example, when data is given, and that size of the data is very much less, and if we have to increase the size of the data, we can use GAN network, which will generate the fake data of the similar type. In deep learning, we have a lot of hidden neuron. It is a stack of the many hidden neurons. So obviously, to train the deep learning network, we need a great data, a huge amount of data. But in some cases, the amount of data we got, it is not sufficient to train the deep learning network. So in that case, we can use generative adversarial network, which will generate some fake data. It may be images, video, or it may be speech signal. So by using that fake data, we can increase the size of the data so that our deep learning network can be trained. So in generative adversarial network, we have mainly two deep learning network. First one is the generator and second is the discriminator. These two blocks are the main building blocks of the GAN network. The function of the generator is to generate the fake images. The input of the generator, initially we give the noise distribution. That noise distribution is taken from any Gaussian distribution. And this discriminator, it will differentiate between the training sample means original image, and the images which are generated by this generator. And accordingly, it will decide whether it is a fake image or an original image. After that, that loss function will go back to the generator. It will take that loss function and accordingly, it will change the parameters. These parameters are weight and biases to generate the image which is identical to the training sample. So in this case, generator and discriminator, they are working opposite to each other. That's why it is called adversarial network. So this is a block diagram for the training of the discriminator. So in this case, the main block is the discriminator. Discriminator has the two input. One input is the original data. So here we have the real world images. True data is given, sample images are given. And second input is the fake data, or it is generated through any latent random variable. Some noise distribution is given. From that noise distribution, it will generate the fake data. The function of the discriminator is to differentiate between the fake data and the original data. And accordingly, it will decide whether it is a real or fake. This green dot represents real and this red dot represents the fake data. So the loss function accordingly calculated. This loss function will go to the discriminator as well as to the generator. So the weights and biases of the generator as well as discriminator will be updated according to this loss function, so that the generator will generate the data which is very much similar to the original image. So this is the block diagram which shows the training of generator. This loss which is given by the discriminator will be backpropagate to the generator, so that weight and biases or the parameters of the generator will be optimized, so that it will generate the data which is very much similar to the real data. So this example shows the image synthesis using GAN. So originally only very less number of images has been given. In this case, we have 4 modalities given for the MRI images, which are T1, T2, T1 star and flare images. So the data is very much small, the data size. So what we do, we apply the GAN to generate the synthetic image. So these are the images which are shown in the second row and the third row, which are generated using GAN. So these images are very much similar to the original images. So this is the main function of the generative adversarial networks. Now, what are the application of the machine learning for medical image analysis? So the first application of the machine learning or deep learning for medical image is segmentation. So for example, MRI images are given or CT images are given. MRI images of brain is given, so we have to extract a particular area. For example, hippocampus or substantial nigra, gray matter, white matter or fluid. We have to extract that particular area. So that segmentation can also be done using deep learning or machine learning. Second is the lung segmentation. So for example, CT scan is given. So in that CT scan, we have to segment only the lung area. So obviously we use machine learning or deep learning network for the segmentation of the particular region of interest from that medical image. Next is the registration. So we have the machine learning model, but the data is given to the machine learning model is coming from different scanner. It may be coming from the Siemens, it may be coming from Philips, it may be coming from the GE or different scanner. So all the scanners have different acquisition properties. So all these images should be registered to a particular or a standard template, so that this machine learning model will work efficiently. And this process is called the image registration. So in image registration, whatever data is coming, it may be from different sources, different scanner, different acquisition parameters. All this data will be registered to a standard template or standard data. So this is also done by the machine learning or deep learning. For example, MRI registration or CT scan registration. Third application of the machine learning is computer-aided diagnosis. Computer-aided diagnosis means, for example, we have tumor, we have cancer, or we have any type of the disorder, for example, Alzheimer, Parkinson, any type of disorder, any type of disease is there. So if we have to categorize that particular sample, whether it is disease or is it normal or is it in the intermediate stage, so that type of diagnosis is also possible using machine learning classifiers. Next is the image synthesis. Example of image synthesis we have already seen in the previous slide, that is using the GAN. So for example, in some cases it may also happen that MRI images are given, and from MRI images for the brain we can also generate CT images. So this is also possible using the machine learning or deep learning algorithms. So all these are the application of the machine learning or deep learning for the medical image analysis. So during pandemic in COVID-19 also, this deep learning or machine learning classifier plays a very important role. How it plays? So for first example, some X-ray images are given. These X-ray images are given for the lungs. And from these X-ray images, we have to diagnose whether it is normal, whether pneumonia is there, normal pneumonia is there, or whether that image is of any COVID patient. So all these images are given into the pre-trained deep learning network. So I have already given the example of the pre-trained deep learning network. It may be ResNet, InceptionNet, maybe mobile net, SqueezeNet, EfficientNet. Lot of pre-trained networks or models are available in the Python library as well as in the MATLAB library. We can use anyone and check the performance result. So all these are the deep learning network. So these consist of the convolutional layer, pooling layer, activation function, and then finally the fully concatenated layer, and then softmax layer. Softmax layer is the classifier which classify the input image into a particular category, whether that image is of COVID or normal. So using deep learning, we can classify any CT scan or X-ray for the COVID patient into a particular category. Next use of advantage of the deep learning in COVID-19 fighting is the mass detection. So it can be used for the surveillance. So some entrance is there in that entrance in that public place. At that time, mask was compulsory. So it will segment the face images. It will segment also whether mask is there or not. So it can report accordingly. So for mass detection also, for the surveillance purpose, we can use deep learning. Next is the social distance detector. So deep learning model is also used for the social distancing detector. So during COVID, during this pandemic time, it was necessary to maintain the social distance of at least 6 feet between two people. So how a person can detect it manually? It is not possible for each and every person to detect it. So for that case also, we can use machine learning or deep learning network. It will use segmentation part, and that is done by this bounded boxes, and then it will measure the distance between two people. So in this way, it will also work to measure the distance or to maintain the social distancing between the person at the time of the pandemic. Ma'am, can we take the break now? Then we will
Yes,
start
ma'am.
with dimension.
Okay, okay, ma'am.
Okay, ma'am. I'm taking 5 minutes break. Then I will
Oh,
start
okay,
with the
ma'am.
dementia and
Okay.
Alzheimer disease.